Assalamualaikum warahmatullahi wabarakatuh. My name is SOFEA binti REZEKI SHAHRUL. I will be presenting the simulation of this single-phase induction motor and three-phase induction motor. The findings of these two labs will be analyzed and discussed. The purpose of this video is to show some comparison between single-phase induction motor and three-phase induction motor. The comparison is made from certain aspects which include circuit diagram, total time, speed, efficiency, and starting torque.
By using PSIM, we will construct the circuit. Both circuits contain sinusoidal voltage source, wattmeter or kilowatt-hour meter, squirrel cage induction machine, speed sensor, torque sensor, mechanical electrical interface block, and load resistor. For single phase, the power source is single phase supply, while for three phase induction motor, it requires three phase supply which is 415 volt. The difference between these two circuits is for single phase induction motor, the capacitor is placed in series with auxiliary winding. This single phase induction requires a run capacitor to energize the second phase winding, which is auxiliary coil, to create a rotating magnetic field while the motor is running. Start capacitors briefly increase motor starting torque and allow a motor to be cycled on and off rapidly. Additionally, for three-phase induction motor, we will be adding three-phase var meter and three-phase VA power factor meter. For single phase, we vary the capacitor and voltage, while for three-phase, we vary the number of poles and load resistor value.
Next, I will be making comparison of the total time. As you can see here, the total time for single phase is 40 seconds. When the value of capacitor and voltage is reduced, the longer the system takes time to reach the steady state condition. That is why the total time for single phase induction motor is higher than three phase induction motor. The total time is important so that we can measure the output waveforms obtained at the steady state conditions. In this case, for three phase, the total time is 10 seconds, since the time the circuit started to reach the steady state for three phase is around 2.5 to 3 seconds. The speed of three-phase induction motor is slightly higher than single-phase induction motor. The speed of induction motor for three-phase is changed from both stator and rotor side. Speed control methods of induction motor can be done by changing the number of stator poles. This method is generally used for squirrel cage induction motors, as squirrel cage rotor adapts itself for any number of stator poles. Additionally, the speed controls of three-phase induction motor from rotor side are further classified as adding external resistance on rotor sides. This explanation is for three-phase induction motor. Three-phase induction motor efficiency is high compared to single-phase induction motor. In a single-phase induction motor, the windings are excited from a single source. As only one winding transfers all the current, the efficiency of the single-phase induction motor is less. Starting torque for three-phase induction motor is higher than single-phase induction motor. As you can see from the single-phase torque waveform, the starting torque for single-phase induction motor is 0. For single-phase induction motor at starting, both the flux components are exactly opposite to each other and are equal in magnitude, so they cancel each other and hence net torque produced by the rotor at the starting condition is 0, and single-phase induction motor is not self-starting. We can say that the major difference is that single-phase induction motors are not self-starting, while the three-phase induction motor are self-start. Thus, we can conclude that the single-phase motor are more reliable and are a better choice for driving small loads such as in appliances, in homes and office, while the three-phase motors offer best performance for driving heavy loads such as in industries. That's all from me. Thank you.